Yeah, I've never thought of that being an explosion. Okay. Let's do this one.
Okay.
So Dan is gliding on the skateboard at 4 meters per second. He suddenly jumps backward off the skateboard, kicking the skateboard forward at 8 meters per second. How fast is Dan going as his feet hit the ground? Dan's mass is 50 kilograms. Skateboard's mass is 5 kilograms.
Okay.
So skateboard at 4 meters per second. Dan is gliding on the skateboard at 4 meters per second.
He's 50 kilograms.
Yes.
Skateboard's 5 kilograms. And 4 meters per second?
Yeah.
Okay. Okay. He jumps off, the skateboard goes rolling off. How fast?
Kicking the skateboard forward at 8 meters per second.
And you wonder how fast he's going.
Yeah. So this momentum would be so the initial momentum would be 20, right? What do you times 4 and 5 and then add 50?
Well, you take the initial is the total mass times the velocity.
Oh, okay.
So what's the total mass?
55.
Yeah. So that's 120. Okay.
So you do 55 times V.
Well,
Oh, it is 50 because the skateboard is.
yeah.
It's not there.
All right.
Do you want to find the momentum of the skateboard, or is that necessary?
Yeah, it is, so this was your whole system, right? This is everything you took your momentum of. So in order for that momentum to be conserved, you have to look at both parts still, right?
Okay, so 5 times 8.
So when you have an explosion, you're going to have multiple parts afterwards. You have to look at the momentum of each individual part.
Right. So P, so it is equal negative 40 over 50.
Well, so this was our initial.
All right.
So what does this all equal to?
120.
So you have 50 equals 120 minus 40. Oh, wait a minute. Yeah, 80 over 50, yeah. And that's 8/5, which is 1.6. Yeah.
Okay. So, the final momentum, like when you're writing out the formula, the initial momentum and the final momentum are always equal.
Mm-hmm. Whenever it's a conservation of momentum, yeah.
Okay.
The way, and that's as long as you like keep the whole system together. So, yeah.
Okay.
And that's as long as there's no forces in between your before and after, too. So, like, for example, when you throw the ball and it hits the ceiling and it bounces back down, the reason the momentum wasn't the same from the beginning to the end is because of the force of the ceiling against the ball. So. But then you can actually do stuff like, I'm not sure if you'll have to do a problem like this, but you can do things like a shell is fired, it gets to here, and then it explodes, and one piece goes up like this, and the other piece goes like this, or something like that. And using conservation of momentum, so you do kinematics up to this point, and then you'd use conservation of momentum to figure out the velocity here, the velocity here of those pieces. And then you can find out how far it actually went, that kind of stuff. So.